Okay. Problem says at x equal 3, the function given by this, at x equal 3 is this function undefined. Hands up if you know the answer to A. Just show me your hand. Is this true or false? Is at x equal 3, is that function undefined? Why or why not? Show me your hands. At x equal 3, is that function undefined? Why or why not? It's actually a very simple answer, so don't overthink this one. Let's go, Elena.
Not because you can plug in the 3.
Very good. It says right here I can plug in a 3. If I plug in a 3, I get 6 times 3 is 18. So I just figured out that f of 3 has a value of 9. So this is wrong. So it's definitely defined. Can we do it? Point 2 for later. Okay, everything else is talking about being continuous versus differentiable at x equal 3. So your flashcard memory should be telling you that f is continuous at x equal 3 as long as the limit as x approaches 3 from the left is the same as the value of f at 3 is the same as the limit as x approaches 3 from the right. You don't need me to talk more about that. That's just reviewing Unit 1. But you do need to have a flashcard that tells you this. Reminder, the next test covers the whole semester. So you'll never be able to have, look, there's a secret though to being successful. You'll never be able to have enough practice problems to ever cover the whole semester. There's too many. So the key is to have a really good flashcard deck with cards like this in it, so that when you study for the test, you go, oh, that's right. I remember doing problems where I had to use this. That's what will help you get a good score. So, question? Cool. So hands up. Who can tell me this value here? Just raise your hand, please. What's this going to be for this app? And let's go Aisley. 9. And how did you find it, Aisley? Perfect. So Aisley looks up here. She goes, x is less than 3. So I don't plug in 3, but I plug in very close. So very close to 3 squared is going to be close to 9. So this limit is precisely 9. When you knew it? Point 2 phrases. You already figured out f of 3 is 9. Hands up for this one. Show me. Who knows this limit? Let's go, Rachel.
9.
Tell me how.
Just the same thing with the bottom equation.
Perfect. So I'm using this because x is bigger than 3 a little bit. So it's going to be really close to 9. So the limit is exactly 9. How many knew it? Point 2 for Rachel. So we know the function is continuous. So it's got to be this one. It could be this one. It is continuous, so it's not that. I'm going to pay 4 points if you can answer this one. Everybody can get it. I know that C is the wrong answer without doing anything. Why? How do I know that C is incorrect? I don't have to do a single thing, but just remember definition. Let's go, Sarah. Before I even did that, yeah, no worries, 2 points for that. So before I did any work, I knew C was the wrong answer. How do I know that? Let's go, Chris.
Is it because it's already provided that C not differentiable can't be continuous already?
Let me say it back to you. I think you said it right. I just want to say it again. For a function to be continuous, for a function to be differentiable, the function must first be continuous. There's no way to be differentiable and not continuous. To be differentiable must first be continuous. How many knew it? 4 points. Okay. We need to repeat that. Awesome. Okay, I've got to figure out if the function is differentiable. We have talked about the differentiable means you can find the slope anywhere, okay? But there's a technical definition for differentiability that you now need to have flashcarded and memorized. The good news is it's really easy to memorize because it looks just like this, except that the definition is, okay, the function must first be continuous, and if f is differentiable, so if f is differentiable at x equal 3, then first of all, f must be continuous. So it's like you have to verify this first. Like you don't keep going if this isn't true. I have seen AP questions where if you don't verify this, they trick you into the wrong answer. So this must be true first, then the following must also be true. The limit as x approaches 3 from the left of the derivative must be the same as the value of the derivative at 3, which must be the same as the limit as x approaches 3 from the right of the derivative. So easy to memorize because it's the same pattern. Question, please.
So it's basically the same except it's
With the derivative. Yep. 2 points. Okay, but I need to find f prime. Finding f prime is also really easy because here's my formula for f. And f has 2 formulas simply because you use one formula for this portion of f and another for this portion. So f prime is going to be 2x whenever x is less than 3. Okay? And then 6 whenever x is greater than 3. Raise your hand if you notice something I did different between here and here that you probably thought, wait a minute, why did he do that? What did I do that's catching you? Most of you will notice. Like I did something from here to here that's like, whoa, wait a minute, why did he do that? What are you seeing? For Charles?
Greater than or equal to.
So I did put an equal here. How many saw it? 0.2 for Charles. Don't put the equal sign until you verify that there isn't a corner or vertical tangent. You really don't know whether you can put an equal or not. Okay? The function's continuous. The function will be differentiable as long as there's not a corner or vertical tangent.
How did we even figure out that? Like all of that?
So here's my formula for all the values of f whenever x is a value 3 or less. So if I simply take the derivative of this, good question. Point? Anybody else? Please.
How do you know there's a corner?
We're going to find out in a second. So what I always teach is don't put the equal sign until we know. So just keep going. Very good. Awesome. Okay, now we're going to check this. So you want to find the limit from the left of f prime. So please raise your hand if you can tell me what is the limit as x approaches 3 from the left of f prime. Good for hands. Let's go Koji.
6.
So Koji looks up here and he says when x is less than 3, it's going to be really close to 6, so the limit's value is exactly 6. How many saw it? Okay, 0.2 for Koji. What is the 6 representing? What does that mean? What does the 6 mean? Sydney?
Is that the tangent slope?
So that's the tangent slope of f. Where?
X equals 3.
Perfect. X equal close to 3. It's not exactly x equal 3, but x equal really close to 3. So if I had a picture of f, and I'm at an x coordinate that's really close to 3, just before 3, I'm getting a slope of 6. How many knew it? 2 for Sydney. So down here, we know this is 6. We don't know the middle yet. So now I check the other side. So raise your hand, what belongs there in the green? Dawson?
6.
So Dawson looks up here, he says, oh, x is a little bit bigger than 3, so the slope is 6. So if the slope prior to 3 is 6, or getting really close, and the slope after 3 is also really close to 6, we do not have a corner. A corner is caused when the slope changes from one side to the other of the point. Like it's an abrupt change in slope. Because the slope is the same or infinitesimally close to the same, we're okay.
So if there is a corner, those numbers will be the same because it's like coming from the left is different than coming from the right is different.
Mm-hmm. Like here's F, and F looks like this. And this is x equal 3. The slope right before 3 would not be the same as the slope right after 3. That's the corner.
So you might not be able to see this if it's just the F, because it's just about the position. But because it's about the slope, that's what it's...
Perfect. Because look here. So F, so remember, F finds the points, right? So answer this, Josh. Is the point just before, is the y coordinate just before x equal 3, really, really close to the y coordinate just after x equal 3? Yeah, so the points are really close. That's why the function's continuous. But the slopes can be drastically different. Make sense?
Yeah.
Good work. Yeah? Cool. So we know this is 6, this is 6. So there isn't a corner. The only other thing that can cause the function to be not differentiable, because the function's already continuous, would be a vertical tangent. Well, vertical tangents only occur if you get a slope that's like number over 0. Number over 0. These slopes are never going to be some number over 0 because there's no denominator, so I'm good. So I can put the equal sign now. The value of the slope in the middle is going to be 6 as well. So continuous and differentiable. Correct.
So let's say one of those had like
You could possibly have a vertical tangent. We good? Okay, please.
Can you explain again why it wouldn't be D, like we know it's D, but like why it wouldn't be D again?
So are you comfortable that the function is continuous? So for the function to be differentiable, first, continuous, shut me back. Second, can't have a corner or a vertical tangent. This definition is going to help me figure that out. So I found the limit from the left and the right, found those two to be the same. So the slopes on either side are the same. So that means no corner.
Oh, right.
Vertical tangent can't have it because these don't have a denominator. I was pointing to the wrong thing earlier. Look up. You don't look here for a denominator, you look here. We're trying to see if the slope can ever be number over 0. So I pointed to the wrong place. Okay. The homework is the first packet, 1 to 24. Okay. There are a few problems in the packet that deal with what's known as the mean value theorem. Okay. For example, problem number 2. So I will post a video of problem number 2. I did it in first period today to help you with that. It's not really that complicated. If you have trouble, you can come talk to me. So mean value theorem, check the video. It only lasts like 5 minutes. It's really short. I will make another video in fourth period of, I think, problem 14 or 10. We'll do another mean value theorem in fourth grade today as well, so there'll be some videos there to help you. Good work. You're welcome.
Really?
Don't forget this.
Anything serious? Wait, who did you guys play in the paintball? We were at like a cabin. What board did you guys go against?
It's more surprising thing. So you think, so the answer is more surprising you can.
So I had that.
Like,
I don't know what to do with that, but it seems different.
so it's just.
So they say it's okay to read it?
Yeah, so mine is kind of weird. And so we went and they're like, oh, you have 25% is irregular. Usually it's 20% of your medication. But they're like, because of your age and like don't really do that much, then like it's fine. And then I had another appointment a few months ago. They're like, oh, it's up to 30%, but we're gonna keep you on medication. I'm like, okay. I can't have caffeine, but that's good.
So who's your cardiologist?
Thank you.
Thank you.
I still, yeah, because that's but I have to change.
It's okay. Yeah, I actually had the PVC thing, and I went, and they did a whole workup. And, hey, you're not sick today. I'm better, so thanks, Kate. They did a whole treadmill test. Yeah. And they came to the same conclusion, like, oh, not enough to worry about, just going on with life. And then a couple years after that, I started feeling more pressure. Like, do you feel it in your chest? Do you feel it?
Not really. I mean, it's like, the worst thing for me is every time I stand up, I like black out for
Feel a little lightheaded, yeah.
And so they're like, oh yeah, drink lots of water. So I've been drinking lots of water, which literally kind of sucks, but I mean,
Yeah,
whatever.
you gotta do what you gotta do.
And my mom, she's like, I'm so worried about that, but they're not fall over. I just got into this when I stand up.
No, I can relate very much. That so for me, they kind of said the same thing. And I started feeling this pressure, so I went to a different cardio. Oh no, that's right. And one day I stood up and I didn't pass out, but I felt kind of extra dizzy.
Yeah.
And I went, and that's weird.
Yeah.
So my wife's an ICU nurse, so she had me come to the ICU. She hooked me up to the heart monitor.
That's the best. You're like, hey, at least I've got someone who like knows competent in handling anything.
And she looks at the monitor and she's like, oh yeah, you're in AFib.
Oh my gosh, that's scary.
Yeah, that's bad.
Yeah.
And
Is it not like pre-heart attack?
it can be a problem.
Yeah.
It's not a good thing.
Yeah.
They don't want you to get
Uh-huh.
So they took me to the emergency room. There's kind of a long story. That's the thing too long. So anyway, I ended up at another cardiologist. He's like, oh, your heart's enlarged, and we
Oh my
gotta fix
gosh.
this. It's like a week later, I had what's called an ablation.
Uh-huh.
You've heard all of this, yeah. So I had that, and then since then, it's just been trying to get it to work with medication.
Yeah.
And I thought it was kind of better. Like I got to where I wasn't having
Morning, guys. This is Calvin and Adam. Please stand for the Pledge of Allegiance. I pledge allegiance to the flag Attention wrestling managers and staff people. The Lone Peak Wrestling Team is looking for a couple of individuals to help out this year as managers and staff people for dual meets and tournaments. If you are interested in helping out the wrestling team, please stop in Mr. Wallace's room, 905 in the trailers for more information. Any girls who are interested in girls football, come Thursday to room 614 at 2:30 to 3:30 to learn more about football. Free hot chocolate and donuts. Those athletes interested in wrestling for the Lone Peak Knights wrestling team this year should stop by Coach Wallace's room, 905 in the trailers, for sign up and to get more info on this year's season. The season starts November 11th, and you need to have your Register My Athlete completed, as well as the current physical. Come talk to Coach Wallace, and he will give you all the info you need to join this year's Lone Peak wrestling team. Sophomores, if you like to be a leader and want to gain new leadership skills, you should apply to attend the Hobby Youth Leadership Seminar. For more details, see Captain Tucker in the Counseling Center. Registration for live interactive distance education classes through UVU is starting today. See Mr. Wynn or your Lone Peak High School counselor for details. 3 cadet classes are only $15. Girls basketball tryouts are next Monday and Tuesday, November 11th and 12th. Monday at 3:30 and Tuesday at 3:15. Register online at registermyathlete.com. Any questions, contact Coach Warner. There's the ASL Honor Society service opportunity today in Miss Terry's room, room 911. Any dancers interested in checking out the dance program at UVU, there is a UVU High School Dance Workshop just for you on Friday, November 22nd. Talk to Mrs. Diallo in the dance room for more information about this school excuse field trip and how to sign up. Another section of yoga has opened up for semester 2, period B6. Talk to your counselor to be added to the class. Lunchtime service is tomorrow during lunch. There's also a football game Friday at Kearns, and it's in Maroon now. Everybody come, and volleyball plays on Saturday, and the Freedom Formal is Saturday from 9 to 11. Everybody come. And remember, Knights, unite the peak.